Okay, so as promised, this is the video of the class that I was going to teach on Wednesday night. Um, so I think you're going to find that most of the stuff in this section, this first section of chapter 7, is pretty straightforward. It's about the fundamentals of probability and some of the vocabulary words that we need to have in place in order to really talk about probability. So for the fundamentals, the first thing is we need to talk about what an event is and what an outcome is. And when we talk about an experiment here, an experiment is not the same thing as you manipulate something and then you're trying to measure the response, like giving people a diet pill and then seeing how much weight they lost. An experiment in this case is just something that that will have an outcome, right? And then I think we'll see what we mean by that in a couple of examples. Right, so an event is a particular outcome or a group of outcomes. And again, I think if I show you some examples of this, it's fairly clear what I'm talking about. And then the sample space is the set of all possible simple events. So let's say, and then a compound event is a collection of simple events. All right, so let's get to an example. So suppose that you roll a die and you note the number of pips. Pips are just the marks on top of a die. So an example of this would be the experiment is just the rolling of the die. Okay? The sample space is all possible outcomes. So if you roll a die, the possible outcomes are 1, 2, 3, 4, 5, 6. So the sample space is just 1 through 6. An example of an event. So an event might be the event that the die rolls lands on a 3. Okay, would be an event. Another example of an event would be the roll of the die is an odd number. Okay, so that would be a 1, 3, or a 5. Another example of an event could be the result of the roll is greater than or equal to 5. Okay, so that would be a 5 or a 6. Okay, and then those last couple examples are really compound events. Probability of the event of a 5 or a 6, or the roll of the die is even or a 1. Okay, would be another compound event. All right, and then we're going to talk about the probability of these. And these first couple problems are fairly straightforward because the outcomes are all equally likely. All right, so let's say that we roll a six-sided die, and we're going to assume that the die is fair. And suppose I want to know, this notation means what is the probability that we roll a 2? All right, so this is a very simple example. There's 1, 2 in the sample space. There are 6 outcomes in the sample space. So the answer to this question would be 1 out of 6. Okay, and you could write that as 1/6, or you can also write that as a decimal. It'd be about 0.167. Okay, so either way, it doesn't really matter to me which way you write that. I think on the assignments, they want you to write it as a fraction, so this would be 1/6. Okay, then what's the probability that x is less than or equal to 2? All right, so this means that we rolled a 1 or a 2. The probability of rolling a 1 or a 2, there's 2 outcomes out of the 6 in the sample space, and because they're equally likely, our answer to this would be 2/6, which you could reduce to 1/3. Okay, what's the probability that the roll of the die is even? Well, if you look in the sample space again, there's six outcomes in the sample space. Of those 6, 3 of them are even. So the answer to this would be 3/6 or 1/2. Okay, what's the probability that x is a multiple of 3? So again, there's 6 outcomes in the sample space. Of those 6, 2 of them are multiples of 3, namely the 3 and the 6. So the probability of rolling a multiple of 3 would be 2 out of 6 or 1/3. Okay, what's the probability that x is 7? Okay, this one is actually fairly simple. The probability of rolling a 7 on a 6-sided die, it ain't ever going to happen. So that probability is 0. Okay, what's the probability that x is not a 2? All right, so again, in the sample space, there's 6 outcomes. Of those 6 outcomes, 5 of them are not 2. So the answer to this would be 5, 6. All right, another example of this would be, suppose you've got a bag of 150 M&M candies. Okay, the number of each color is summarized in the table. Okay, so there was 17 blues, 23 reds, and so on. We're going to reach into this bag and draw out one single candy. And the question then is, what's the probability that the candy that I drew out of this bag is red? All right, so again, there are 150 candies in this bag. And of those 150, 23 of them are red. So to calculate the probability of getting a red M&M, if they're all equally likely of being drawn, would be 23 out of 150, which is about 15.3% or 0.153. Okay, and again, I don't really mind which way you write the answer. I think that your online homework is going to want you to write it as a fraction. So 23 over 150 would be the proper answer here. Okay, another question about this is, what's the probability of a compound event? Okay, so this would be, what's the probability that we're going to get either a red candy or a blue candy? All right, so if we notice that there's 17 blues and there's 23 reds, so we could say that there's 17 plus 23, that's 40. 40 possible successes here out of a possible 150. So 23 plus 17 is 40 again out of 150. That reduces down to 4/15, which is about 26.7% or 0.267. Okay, and again, I don't really mind which way you give your answer. The WebAssign is going to want you to write it as a fraction. Okay, I think it'll accept 40 out of 150. I don't think you have to reduce it. Okay, and then another event would be, what's the probability that we got something that's not yellow? All right, so I want to show you two ways to do this. First of all, we could calculate the probability that the candy that I drew is not yellow. So that means it was either blue, red, green, orange, or brown, right? And the probability of that happening is just add up all those events. So 17, 23, 31, 23, and 17 out of 150. Right? So that gives me 111 candies that are not yellow out of 150, and that's 74%. Okay, this is the hard way to do it, actually. The easier way to do it is to think about, what's the probability that I do get a yellow one? The probability of drawing a yellow candy is 39 out of 150. Okay, all these probabilities have to add up to 100%. So I could just say, take 1 minus the probability that it's yellow. All right, so it'd be 1 minus 39 out of 150, which also gives you the probability of 74%. Okay, we're going to see later on that this is called the complement rule. The probability that an event does not happen is 1 minus the probability that it does happen. All right, another example. Suppose that you've got a deck of playing cards, okay, and a lot of times I have to explain to my high school students and college students that what the playing cards are. I'm going to assume that all of you are familiar with poker cards. And so let's find the probability that you draw a card out of a deck and it's red. All right, so the sample space is, there are 52 cards in a deck. Okay, 13 of those cards are diamonds and 13 of those cards are hearts. So there's 26 red cards out of 52. So the probability of getting a red card would be 26 out of 52, which reduces to 1/2. Okay, what's the probability you're going to draw an ace? All right, so if you're familiar with cards, there are 4 aces in the deck. There's a total of 52 cards in the deck. So the answer to this would be 4 52nds, which will reduce down to 1/13. All right, what's the probability the card is not a 7? All right, so this one is actually easier to use the complement rule. The probability that the card is a 7 is 4 out of 52, or 1/13. So the probability the card is not a 7 is everything else. So that would be 48 out of 52. Or you could also say that that reduces down to 12 out of 13. So 12/13 is the probability that you did not get a 7. All right, not a heart. There's 4 suits in the deck. The probability that you did not get a heart would be 1 minus the probability you did get a heart. So the probability of drawing a heart from a deck of cards would be 1/4 or 25%. So the probability of not getting a heart would be 1 minus 25% or 75%. Okay, a face card. So a face card is a jack, a queen, or a king. Okay, there are 12 face cards in the deck. Okay, 4 jacks, 4 queens, and 4 kings. So the answer to this would be 12 out of 52, and 12 out of 52 reduces down to 3/13. Okay, so either one of those answers would be fine. Okay, a red ace. Okay, again, there's 52 cards in the deck. There is an ace of hearts and there's an ace of diamonds, which are the 2 red aces. So the probability of drawing a red ace would be 2 out of 52, which reduces down to 1 out of 26. Okay, this means a red card or an ace. Okay, a lot of people will make a mistake on this one and they'll say that the answer to this is the probability of a red card plus the probability of an ace. All right, so if you think about that in terms of the red cards, there are 26 red cards and there are 4 aces. So if you take 26 plus 4, you get 30 out of 52. However, that's not the correct answer, okay? Because if you do it that way, you've counted all the red cards, okay? And 2 of those cards were red aces, all right? So you've actually counted the red aces twice if you do it that way. So the way you should probably do this is think about how many red cards are there? The answer to that would be 26. Okay, and then if the card is also, if it's an ace, there are 2 other cards that would be successes then. It would be the 2 black aces. Okay, so the probability of getting a red card or an ace would actually be 26 red cards plus 2 other aces would give me 28 out of 52. Okay, we're going to talk more about the word or in between some compound events and the word and in between compound events later on next week. Okay? Okay, and a couple of questions that I want to do here. Suppose that we roll 2 dice. And again, this is going to get into what we do next week. And I just want to go through a couple of these problems. Okay, so what is the probability that the red die is a 5? All right, so the probability that the red die is a 5 is just 1 out of 6. Okay, that's an easy question. Okay, what's the probability of rolling doubles? All right, so if you consider how many different outcomes are there when we roll 2 dice, okay, so the red die could be 1, 2, 3, 4, 5, or 6, and the green die could also be 1, 2, 3, 4, 5, or 6. All right, if you think about how many outcomes there are 36 different ways that we can roll 2 dice. Okay, 6 different outcomes on the red die, 6 different outcomes on the green die, 36 different outcomes. Of those 36 outcomes, there are 6 doubles. There's double 1s, double 2s, up to double 6s. Okay, so to answer this question then, what is the probability that doubles is rolled? There's 6 doubles out of a possible 36 rolls. So 6 over 36 or 1 out of 6. So this probability is 1/6. All right, and then I think I want to stop there because these other questions get into some conditional probability and some compound events, and we're going to talk more about these next week. So I'm going to pick up this PowerPoint again next week, and we'll be able to answer some of these other questions. Okay, they get into a little bit more complicated forms of probability. All right, so that should get you through the first 2 assignments. It'll be 7.1.1 and 7.1.2 on your Newton assignments. So have a great Thanksgiving break, and I will see you all next week on Monday. Be safe, and I'll see you then. All right, bye.